Wow, okay, cool. Hi, everyone. So, like Sarah said, my name's Sam. I'm a staff engineer here at Betterment. I've been here for about 4 years now, and I've gone from working as a product engineer, building features for our consumer application, to working sort of more off the critical path. So nowadays I work primarily on our engineering efficiency team, which means that basically I'm focused on making sure that all the engineers that work here have the tools that they need to build features quickly and maintainably. What I want to talk to you guys about today is integrating HTTP services like a boss. I'm going to start with a little bit of background. Betterment is a financial services company, but more importantly, we have a service-oriented architecture, right? That means that we have a couple different applications that talk to each other internally, and we also integrate with a bunch of third-party services. So these are things like external account aggregators and tools to do identity verification. So integrating with HTTP services is very important to us. So what I want to start with are 3 questions that are pretty much the most important questions to answer when you're building a service-oriented architecture. So the first one is, how are you going to communicate with these collaborator services? The second one is, how are you going to test your apps when they integrate with collaborator services? And the third one is, how are you going to continue to build the features that you build at a fast pace? Let's look quickly at an example. What we want to talk about is when a customer comes to Betterment and they want to deposit money. Typically they do this on a recurring basis, and then that money grows over time, and then hopefully they achieve their goals. Well, when they want to make a deposit, they come to our retail application. That's the nice little castle that we have. They tell us that, and then that little retail application needs to talk to another application in order to process that deposit. That's what we're going to call the trading application, which is our flying pirate ship. So you can see there's a need for some HTTP service integration here. So what I'd like to do to understand sort of how to attack this problem is look at how we might test this feature that we're talking about. So what I have here is some code. It's actually a feature test, which is RSpec language for a high-level integration test. And what it's going to do is it's going to, if you look sort of midway down there, it's going to visit a page called transfer. It's going to click on a button, it's going to fill in a form, and then it's going to submit that form, and then it's going to make an assertion that a pending deposit was created. So if we step back a little bit, we can see that that was jumping down to what the test actually does. We also need to do a bunch of setup to make this test work. So you can see there's 2 calls to this thing called stub request. In between them, there's something like 170 lines of code that I've snipped out. Those stub request calls are using from a library called webmock that's turning off network connections, because in our test suite we don't want to be making real network connections. So let's take a little bit of a deeper look at this, right? So if we zoom out, we can see the top of our feature spec here. So it's a tiny little feature spec disguised in what amounts to several hundred lines of crap. So the first thing that happens here on line 3 is we're stubbing our request to return some JSON, and then we're still stubbing our request, and still, until eventually we get back down to the body of our test that we actually care about, right? So let's talk about this a little bit, right? So how do we want to test? Well, we definitely don't want to do that, right? No one should ever write a test that looks like that. It's going to be incredibly brittle. It's a poor approach to testing the service integration. So what I want to explain is what went wrong, right? So what we can see is that we didn't anticipate when we built this feature spec that we were going to have to stub not just the request to post to our trading system about a deposit, but also that we would need to stub the trading system's representation of a user. So we need to go out, and the first first request was asking, hey, tell me everything about this user that is about to do this action. In order for our test to work, we needed to stub that request. So what we can see is that at the very bottom we have just a listing of all the files that are in our features folder, which is amounting to about 81 files. And that means that for every test that we write, almost every one of those tests is going to need the same stub for this user data. And the difference between the stubs in those tests is going to be probably trivial, annoying things like the ID of the user and maybe some of the nuanced little differences for each of the users that we care about. And what we can find is that there's just no reasonable way for us to share the stubs between our tests. And since we have a lot of tests, that's going to amount to a lot of pain. So what I want to talk about is how we can make this test look like this one. So what if I told you it was possible to reduce this test, this feature test, down to just those 5 lines of feature testing code by leaning on some libraries? I think you'd probably find that very pleasing. So before we dive into that solution, I think it's important to take a step back and understand how we came to the solution. We're going to go, and basically we're going to go on a little journey. And we're going to answer our questions that I posed before, right? So the first question that we had was, how do we communicate with the service? Our answer is going to be use HTTP and REST. Then we're going to talk about testing. How do we test? We're going to use a thing called a contract test. And the last one's a little bit more nebulous, right? We're going to want to revisit that and think about it some more. So first off, how do we communicate with the service? So I already said we're going to use HTTP and REST. The reason that we're going to do that is because together they sort of form the lingua franca of the internet, right? So inevitably, if we are integrating with external services, we're going to need to write at least one integration that uses does an HTTP REST API. So given that, we don't have a strong reason to build multiple ways to integrate with services. If we have all the control that we want over our internal way of building things, we should probably aim to do that the same way that we would for most of the external ones we're going to lean on. Second, and maybe equally important, REST is an incredibly semantic, appropriately flexible, and evolvable sort of approach to building APIs on top of HTTP. And it's incredibly familiar to all of us as Rails developers. It's built right into the routing system. So HTTP and REST, that's our go-to thing. We're going to endorse using Faraday. It's a really straightforward library that integrates with a ton of HTTP adapters that is easy to build abstractions on top of. Next up, we want to talk about how we're going to integrate, how we're going to test these service integrations in our given app. So I mentioned before this term contract test. It's an idea that's been around for a long time. The principle that underlies it is that when you, in your app, integrate with a collaborating service, you're implicitly defining a contract, right? So there's 2 sides of that contract. There's the consumption side, which is your app, and there's the producer side, which is this collaborator service. And what you should be attempting to do when you want to test that is document what it is that, as a consumer, you expect to send and thus receive, and also sort of from the producer's perspective, what it is that they're expected to return based on a given set of inputs. So that's the idea behind a contract test. Now we should talk about why we would want to use something like a contract test. So it boils down to 3 simple things, right? They're fast because they actually endorse that you don't run actual network connections in your test suite, so there's no I/O, and as a result, they end up being reliable. So there's no reason for them to flake other than you actually breaking the test, right? They're much more like unit tests in that way. And then they're explicit, right? So they usefully document the contract that you expect to have with the producer service as a consumer. And so if a test breaks, then you have a pretty strong indicator of why it broke and how you're going to fix it. And then sort of in order to understand completely why contract tests are worthwhile, we should also think about what an alternative would be, right? So an alternative to contract tests are actual high-level system integration tests. So that would be something like run all your collaborator services locally and in your continuous integration environment, and actually have your tests make requests to those collaborator services, and sort of do the same things that a contract test is going to do when it comes to expectations and verification. And sometimes even maybe write like a feature test that actually goes all the way across those boundaries. And the reason that wouldn't be good, or I think that it isn't good, is that it is essentially the inverse of the three things that I said were really important before, right? They're not fast because they have to do I/O. They can be expensive to orchestrate, and they're not really that explicit, depending on how you write them. You might actually have to do a bunch of digging to figure out what went wrong when they break. So that's why contract tests. So how are we going to write contract tests? We're going to write them using WebMock. I've introduced this tool before. It's great because it turns off network connections in your test environment and forces you to explicitly document when a given test is going to make a certain interaction. Awesome. So the last one I said was TBD. How are we going to continue to build features at a fast pace? The answer is actually we're just going to keep local development simple. How are we going to keep it simple, or maybe why are we going to keep it simple, right? So why are we going to keep it simple? That's because we really need it to be simple so that if you're going to go from one project to another project and back, you don't need to have like a whole set of services set up on your computer, right, in order to test or build any given feature. You don't need an internet connection in order to build stuff. You can build things when you're on the subway, you can build things when you go to the park, whatever it may be. Or you can build things when the office internet goes out. And then the last thing that we want to support, and in the spirit of keeping things simple, is if we do actually want to integrate with a feature in local development, we should be able to, right? We should be able to turn that service or a given set of services on when we want. So if it isn't obvious, that means that we're not going to use any or all of these tools to mirror some cloud environment setup, just so that we can achieve building local features. We're just going to use Rails S. We want local development to be that simple. So I hear you, Sam. Keep local development simple. How, though? How are we going to do that? I haven't said anything about how we're going to do it. Well, it turns out that I'm not the first person to suggest this. Thoughtbot has written. Thoughtbot is a consultancy. They work a lot in Ruby and Rails, and they've suggested through a series of blog posts many over the years that a strategy very similar to this one, right? So the tenets of it are: don't hit external services and tests. Use WebMock to accomplish that and other things. And the sort of magic missing piece here is they also introduce this concept of using fakes to sort of supplement the need for, or to replace the need for an actual collaborator service to be running or available at all times. So let's talk a little bit about fakes. So this is the proposal by Thoughtbot, right? Is use Sinatra, which is a simple web framework that's easy to build little rack apps on top of, and define in it the routes that you care about, the things that you ordinarily would have stubbed in your test before, so you can start to see how this ties back to the test that we were looking at before. And in these fakes, you can actually do useful things that you couldn't do before, like pull real parameters out of the request and feed them back in to the fake response in order to make them richer. In addition, if these fakes exist in your code base with the rest of your application code, you can use things like Active Record to enrich these fake responses with different projections of your data that make them more useful and realistic. There's one last bit. That's what the fake looks like. And then the answer from Thoughtbot about how to set that up, at least in test, is to use WebMock to stub the request. Basically, any URLs that begin with some host or base URL should map into this rack app, and they'll be processed accordingly. So I think that's a pretty great solution, but it falls short in a couple different ways. There are certain things that are missing about it. There isn't a great solution for certain things that we outlined as wanting to have solutions for. So let's talk a little bit about what's missing. So the first thing that's really missing from this is an idiomatic setup stance. So we want to be able to define our fakes in a single place. So we want to know, hey, when I want to add a new fake, or when I want to figure out where some fake behavior is coming from, how do I find it? Sort of in the same vein, we want to be able to answer similar questions about when we register a fake, right? So we'd like to be able to register all these fakes in one spot. And then sort of overlapping with both of those things, but also introducing other value, just convention over configuration would be a super helpful piece to have here. So if we can conventionally figure out whether service is supposed to be enabled based on its name, that would be really useful. The next thing that I want to talk about that's missing is environment-specific behavior. So there is an answer for test in the Thoughtbot solution, but what we want is, in production, we always hit the real service, right? There's nothing gets in the way, there's no hoops to jump through, we just hit the real thing, we never have to worry about it. In test, we never want to hit the real service. Nothing that we do should allow us to hit the real service. We'd rather always hit an explicitly stubbed request through webmock, or hit an implicitly stubbed request through one of our fakes. And then in development, we actually want to be able to kind of have a little bit more nuanced behavior, which is hit the implicit fakes most of the time and by default, and then be able to toggle the service on for real when we choose. So the next thing that we want, in addition to environment-specific behavior, is the ability to auto-load our fakes. So if they're in our code base, we should be able to iterate on the fakes without having to restart our Rails app. You don't always get your fake behavior right the first time, and having to restart can often be a really antagonizing experience for building new features. And Thoughtbot proposed a solution, which is what you'd extract your fake into a gem, and you could run it in an external process, and that's okay, but it's certainly not auto-loading, and it also requires us to stop and restart a separate process whenever that fake changes, which isn't going to be good enough for us. Okay, so this is the last thing that's missing from the Thoughtbot solution, which is the ability to bolt this behavior onto an app that's already out there in production running at 60 miles an hour, right? So, this has got to be relatable, right? You have an app, it's out in the wild, it definitely works. You know that you can't just stop the world to just like rewrite all of the ways that you've integrated with every system that you've ever integrated with. So we need to be able to define these fakes incrementally, and we also need to be able to migrate the existing integrations that we have individually, so like one by one. You don't have to boil the ocean. Cool. So yeah, the problem there is that unfortunately there's no library out there that lets you, a Rails app, integrate that way and gives you the ability to map HTTP requests to an in-process set of fakes in test and development. That was true until today. So we built a gem, or primarily I built a gem. Called WebValve. Takes its name from, it's inspired by webmock. It's a new gem, it's open source as of today. It uses Sinatra-based fakes and webmock, similar to the Thoughtbot approach, but it also supports mapping those fakes into your development environment. So what I want to do is work through that same example we were looking at before, but I want to do it like a boss. So first off, we need to set up WebValve. So we're going to add it to specifically our development and test groups in our gem file. We're going to run bundle install, and we're going to run a generator, and then we're going to drop some config into our RSpec, Rails helper, spec helper, what have you. And at this point, we will have the gem installed. It will activate itself only in development and test. Production will never know it's actually there. And we'll have a config file that's ready to have our fakes registered in it. and development and test, both of them, will now have no ability to talk over the network. They'll all have it blocked by weblock. Cool. So here's that feature spec again. I've gone ahead and collapsed the horrible lines of code so that it's a little bit easier to look at. What we're going to do is we're going to go through and we're going to say, hey, we can reduce it to just these 5 lines of code. So first we're going to look at this initial stub, which is our trading app's user data. So we're going to define a new fake. It goes in WebValve fake trading, which is the name of it. And then it doesn't inherit from Sinatra base. It actually inherits from a special class called a WebValve fake service. It's basically Sinatra base with some additional sugar on top. And then we're going to define our route as we saw it was defined before in our Sinatra fake. And we're going to scoop our JSON out of that other file and hopefully make it a little bit more dynamic and drop it in here. And then we're going to go to our config file. We're going to register our fake. And we're going to also, somewhere in our environment, hopefully maybe you're using .env, you can drop a conventionally named URL in there as the base URL where you would expect requests for this service to go to in test and development. So that means that we're going to get this automatic mapping of requests that start with that host or that base URL to map into this fake, as we saw in the Thoughtbot approach. So you get all the power of Sinatra fakes. They'll be auto-loaded. You can change the behavior while the app is running, and it'll automatically take effect, and you'll get it mapped to the right thing. So we just killed one of our stubs. That's it. You can rerun the test. It's going to work. You're going to be really happy. So now we do the next one. Simple. I snipped out some lines, but this is the whole thing, actually, for this kind of response. If we don't care what the data is that comes back, we're going to get just the status and the JSON, and we're all done. So now that one's gone. We can even, at this point, if we had taken the crazy approach, which I said absolutely not to do, of stubbing those requests like this in all of our tests, we can go through and replace probably all of them with more dynamic, valuable stubs now that we've got this implicit fake built in. And voila, that's it. We've got all the same behavior as before without any of the noise in our spec. So there is one more thing, though. You probably, maybe you know what it is, but we want to be able to use the RealService sometimes, right? So in fact, all that actually takes is setting somewhere in your environment a conventionally named environment variable with a truthy value, and restarting our app, and we'll actually be hitting the real thing. So at this point, we're integrating HTTP services like a boss. And that's it for the the feature spec. I have some summary takeaways here that I just want everybody to hone in on. So new gem, it's called WebValve. It's open source. It's under the Betterment organization on GitHub. It enables us to integrate HTTP services into our app in a different way that allows you in test to not have to stub things that your test isn't focused on. And in development, it enables you to turn services on and off specifically when you choose to, and so that you can test features end to end. And if you're interested in migrating an existing application, we've done it for something like 12 or so. I looked it up today. I think it's actually more like 14 apps to this approach incrementally over the course of a few months. So it's pretty powerful and easy to swap in. So yeah, go out there and check it out. And that's it. If anybody has questions. I think your hand went up first.
Does this work with Ruby 193
So the question was, does this work with Ruby 193? The answer is, right now it doesn't. It probably never will, because we don't, at Betterment, use Ruby 193 anymore. But there's maybe no reason that it couldn't. I'd have to just look at the dependencies and understand if it was worth changing for us.
on that environment variable, on like the switch to if it's hitting all the fakes or going to a real thing, is that an environment variable on a third-party service that you use? And if so, how do you actually integrate that in like each of them, or is it a catch-all? So if my app is hitting 8 of these third-party services, is there a way to turn one on and 7 off?
Cool. So the question was the environment variable that I talked about for turning on and off services. Is it a single environment variable for toggling all of them, or is it an environment variable for toggling? Are there individual environment variables for toggling each of them? So the answer is yes. You have a different environment variable for each service, and the name of it is conventional. So the one that we were looking at was a fake trading class. So we strip the word fake off of it. We use trading, and we look up trading _ enabled in your env. And I think that some of that is customizable, but we're open to pull requests if you have a good reason to change it. Yeah.
So if you're using this on a larger scale integration test where you need to check like state basically between some of the calls, how do you usually like implement that on the test side in terms of storing data between two calls? Do you have that as like just a global variable on Sonata side, or?
Yeah, so that's a good question. So the question was basically how do you make these fakes stateful, right? So the answer is it's a work in progress. We don't have a baked solution that says, hey, do it this way and you're going to be super happy. But the answer today would be to, yes, store the state on the fake that you're actually building, or extract your own little module for the lifetime of your process that will collect the state and let you maybe choose to reset it if you want, etc. What we're thinking of doing is introducing the ability to sort of inject some sort of state container that maybe then could also work in staging environments when you have multiple processes, etc. So it works today. It's maybe not as great as it could be, though. Room for improvement. I think that sounds.
How are you dealing with clearly some projects one team's working on, one team's working on? How do you deal with the other team breaking the contract?
Yeah, so nobody should be. Yeah, so the way that we look at it, okay, there are tools. If you own both sides of the contract, there are other tools out there that are better suited to ensuring that those contracts don't break. One of them, I think, is called Pact, and it lets you sort of ship the tests or the contracts between the consumer side and the producer side. That does create some tedious coupling in your integration, in your test suite. Basically, the rule that we have is that if you change one of these tests, like, I'm going to find you and I'm going to hurt you. People know that if you're changing these contract tests that you're doing something wrong. And the people that actually own those contract tests in a consumer app are supposed to be the people that actually are providing the API from the other team. So if you have your trading people are actually going to be owning the contract tests for the endpoints that I described. And usually that ownership is a good enough mechanism.
How do you deal with forwards and backwards and changes in those cases?
Okay, so the question was, I forgot. The question was, how do we deal with forward and backward incompatible or compatible changes? Really just change in our REST APIs, in these fakes specifically.
In general, it's subtle communication as well.
Oh, sure. Yeah, so I mean, we're all about API versioning, right? So we prefer to throw a URL segment in that says, hey, this is the version 1 of this API. We only make additive changes to existing APIs. And we generally, because we use sort of a backends for front ends approach, so we know what all of the consumers will be for a given API, because if we provide a trading app and we have, let's say, 6 different apps that need to consume account data from it, we're not going to build one account endpoint, we're going to build a specific set of APIs for each of those consumers. So we'll know exactly who it's going to affect. And if we're going to make a breaking change, we're going to bump the version. And we'll leave the API there until we know nobody's using it.
How do you share these apps between different apps?
Can you rephrase that?
So I'm guessing like not like you have serverless services that use the same API.
Ah.
Make sure that those services.
Right. That's a good question. So I think it depends, right? So the question was, how do we share fakes, these fake implementations between apps that actually may consume the same APIs? So the answer is it depends, and it depends basically on whether they're actually consuming the same fake. So for example, if we had this is going to be a challenging one. Basically, we don't, for the most part. If we use the same rules for code reuse that we would for extracting and sharing like models in a Rails app. So if we find that we need to share some models or controllers, we're going to extract them to an engine, and then we're going to share that engine in multiple apps. We use the same approach for sharing fakes. So we have a couple apps that share like a core engine in our system, and we actually put the fakes in there. WebValve has a nifty little bit of support for auto-loading fakes from engines. So you just say that your engine includes fakes, and it'll pull them in. That can definitely be a tricky problem if you're interested in doing things like leveraging the auto-loading and stuff. But there's nothing that would stop you from actually bundling up a fake and sharing it, other than your approach to setting up the URLs that the fake's actually going to serve. Any other questions? No? No? Cool.